Today, we are diving into some really fascinating security research that uncovered a tiny, subtle flaw deep in the foundations of, well, a huge chunk of the modern internet. It's a vulnerability that was just hiding in plain sight, in code that pretty much all of us trust and use every single day. Okay, so to really get your head around this, think about it like this. What if an attacker could secretly scribble a little change onto a single master blueprint? A change that creates a hidden backdoor, a backdoor that suddenly appears in every single house built from that plan. That is the kind of scale we're talking about here. And that's pretty much what these researchers found. They uncovered this subtle weakness in JavaScript called prototype pollution. And it's not the kind of thing that just crashes a program. No, this can hand over complete control. We're talking about what's known as remote code execution in some of the most popular, widely used software on the entire planet. And look, this is not just some academic exercise, right? The researchers went after real, live, in-the-wild applications, the kind of stuff that millions of developers depend on every single day. The hit list is honestly kind of staggering. We're talking about the NPM command line tool. That thing is bundled with every single Node.js installation. Then there's Parse Server, a massively popular backend for apps, and Rocket.Chat, a communication platform used by countless companies. This thing had real, tangible, out-in-the-world impact. So how in the world does this actually work? Let's go back to that blueprint analogy for a second and really break down the core of this attack. It all comes down to a really fundamental and kind of quirky feature of the JavaScript language itself. You see, in JavaScript, most objects are basically stamped out from a master template, which is called a prototype. It really is like a blueprint. If that blueprint says all rooms have windows, then every single room you create from it will just have windows automatically. It's super efficient, but as you can probably guess, it also creates this one incredibly powerful single point of failure. And the pollution part, well, that can be shockingly simple. Let's say you have two totally separate, unrelated objects. All an attacker needs to do is find one little weak spot in the code to get to that shared blueprint and change it. They might add a new property called, backdoor to that blueprint through the first object, and bam. Suddenly, because the second object inherits from that same blueprint, it also has that backdoor. It's been polluted. Now, the researchers came up with this brilliant way of thinking about the whole thing, a two-stage heist. Because you see, it's not enough to just pollute the blueprint. You've got to find a way to actually use that pollution to do something bad. So stage one is the infiltration. This is the prototype pollution we just talked about. The attacker finds a vulnerable spot, what's called an injection sink, and uses it to write their malicious property onto that master blueprint. Then comes stage two, the inside job. Here, the attacker just waits. They wait for a completely separate, totally legitimate piece of code, what they call a gadget, to come along, read that malicious property from the blueprint, and unknowingly execute the attacker's command. The paper itself puts it perfectly with this analogy. The pollution in stage one is like loading the gun. The gadget in stage two is just some unsuspecting piece of code that comes along and pulls the trigger. The attacker sets the trap, and the application springs it on itself. But this is where the researchers had their biggest breakthrough. They have this aha moment. They realized the real danger wasn't just finding these little gadget triggers in individual apps. What if they looked for them in the core engine that powers all of them? What if they looked inside Node.js itself? And that's where they found what they call universal gadgets. These are vulnerable code patterns not hiding in an app's specific code, but in the Node.js runtime that the app is built on top of. That's like discovering a set of master keys that can open the locks on thousands of different buildings just because they all happen to use the same brand of lock. It's a game changer. And they didn't just find one of these master keys. Nope. They found 11 of them. 11 universal gadgets just sitting there, hidden in the core Node.js source code, waiting to be triggered by a cleverly placed prototype pollution attack. So here's the crucial part. How this all comes together. What actually happens when you combine one of these prototype pollution vulnerabilities with one of those universal gadgets? Well, that's when you go from a cool theory to a complete system takeover. And the impact is just devastating. I mean, by polluting a property called shell, an attacker could hijack any command the application tries to run. Polluting env, that lets them inject malicious variables right into the system. And with main, they could trick the application into running a completely random, arbitrary file of their choosing. These aren't just backdoors, these are the keys to the entire kingdom. So let's actually walk through how this plays out in a real-world attack. The researchers' takedown of the NPM command line tool is the perfect example. And this one is a really big deal because this tool is on pretty much every single developer's machine out there. Okay, so here's how the heist went down. Step 1. An attacker publishes a malicious software package. Step 2. Some unsuspecting developer installs it. Now, during that installation, the malicious code pollutes the env property on that master blueprint. Then, maybe hours later, NPM just tries to do its job. It legitimately runs a git command, something it does all the time. But that's when the universal gadget is triggered. It reads the attacker's malicious code from that polluted env property and executes it. Game over. The ripple effect from this research is just huge. It reveals some really deep and maybe a little uncomfortable truths about how we build modern software and the kind of hidden risks we're all accepting. So what's the big takeaway here? Well, first, prototype pollution is not some obscure minor bug. It is a critical vulnerability that can lead to a full system takeover. Second, because of these universal gadgets, thousands of applications can be vulnerable without having a single flaw in their own code. And finally, it just goes to show how the very thing that makes software development so powerful and fast, reusing code and building on shared platforms, is also what creates these deep, systemic risks. You know, the researchers actually named their paper Silent Spring. It's a nod to that famous book about the unseen environmental dangers of pesticides. And it really leaves us with this powerful and honestly a little unsettling question to think about. In this vast, interconnected ecosystem of code that we all rely on, what other silent threats are just hiding beneath the surface?